Okay, so this is number 13 and 7.7, where they would like me to simplify 1 minus sine squared t over cosine t. Oh, that's a good idea. You guys all see that?
What?
You can use the Pythagorean identity, right, on the top there. Really, I'm thinking sine squared plus cosine squared is 1, right? So I want a 1 minus sine squared. So what do I do to both sides to get there?
Subtract.
Yeah. Subtract sine squared from both sides. You get cosine squared is 1 minus sine squared. So I can replace the top with cosine squared t divided by cosine of t. And then we can find a onesie in there, right? So we'll get cosine of t left. Cool, right?
What if you didn't realize that?
Yeah, so if you didn't notice that, you might do this. You might say split things into secant t minus sine t tangent t or something. You guys see where that crap came from?
Oh, because you divided 1 over cosine.
Yeah, I did 1 over cosine secant, right? And then I got minus, I had a sine squared over a cosine, right? So the sine over a cosine is a tangent, and then there's a leftover sine.
Well, then could you get cosine out of that?
When'd you convert?
Because you would get 1 over cosine, and then you flip it over with the tangent. Then your sine would cancel out.
No, I mean, you might notice that again. I think this is about the best you do wandering down this particular path. I think the better path is that one. Another thing you might do is you could take this whole thing, right, and multiply it through by cosine t over cosine t. You guys with me on that? Like that's 1, right? I can do that. So then I get, this is a mess. I get cosine t over cosine squared t minus tangent squared t. And then you could use the Pythagorean identity but with tangents to fiddle this around a little bit. It'll eventually get you back there, but it's kind of messy. I think the best you're going to do without noticing the Pythagorean identity is wander around in the swamp for a little bit. Like if you notice the Pythagorean identity, this is pretty chill. Cool? I would, look, any general philosophy, anytime you see a sine squared or a cosine squared attached to a 1, go check the Pythagorean identity. Like, it might work. If it works, great. Your life is much easier. If it doesn't work, meh, you wasted 2 seconds. If you wander down these paths first, right, then you can waste forever.
I spent the first minute or so on this question seeing if there was a tangent I could pull out of here somewhere. Can you see where it kind of tricks you into that?
Yeah, and actually, if we had done that, so if right up here you multiplied by 1 over,
Yeah.
well, I'm not really allowed to multiply by 1 over cosine t, right? But I could multiply by cosine t over cosine t.
Mm-hmm.
So that would give me a cosine t times a 1 minus what?
Sine squared.
Oh. So let me totally write this out. I'd get a cosine t times 1 minus sine squared t all over cosine squared t, which we could then get into cosine of t minus cosine t sine squared t all over cosine squared t. This is still going to bring me to the same damn spot. Why would I do this?
That's the point where I stopped.
Oh, how about this? What if I left the cosine out? And I had 1 minus sine squared, right? And then I do, okay, this is cosine t times 1 minus, why do I keep writing 1? How about secant squared t minus tangent squared t? And then you have to notice the Pythagorean identity anyway. And this thing is 1. So you get cosine again. But it's still, right, like, however the heck you do this, you're going to end up having to use the Pythagorean identity or not quite getting all the way there. Sorry. There's other, even more horrible ways to do this that we'll learn later today. The half-angle identities, so. Don't worry, we'll just add more to these. I would shoot for the Pythagorean identity anytime it looks even vaguely applicable. It is usually a good option.